One of the things we need to be able to do is to find the inverse of different functions. Now let's just review what a function. A function, as I've said previously, is like a mapping. So we pick up values of x, and we map them to new values. Okay, so this is f of x. It'll pick up an x value, it'll do something with that x value, it'll multiply by 3 and add 4 if it's a linear function, y equals 3x plus 4, and then it'll give a new value. And not just for one value, but for multiple values. It'll take different x values and map them to different y values. The inverse function picks up that point there and then takes it back to the original point, and that is written as f to the minus 1. Now, it's not a power, it's just a way of writing inverse function. So f to the minus 1 is definitely not equal to 1 over f of x. You might recall from your laws of indexes that a to the minus 1 is equal to 1 over a. That is true. F to the minus 1 is not 1 over f of x. So we've just got to be aware of that this is just a way of writing the inverse function. You remember that the cos of x might be equal to some value, say 1 over 2. To find what x is, we go cos to the minus 1 on 2 and put it in, and we'll get an answer. Now that's not 1 over cos. That is, find the angle who has a cos of 1 over 2 or 0.5. So inverse functions, we've already come across them with our trig. It is a way of working backwards. So if we know a function, we need to be able to work out what is the inverse function. So do all functions have an inverse? And the answer is no, not all functions have an inverse. And there is a very easy test, and it's called the horizontal line test. And the horizontal line test is if you can draw a graph of the function. Let's just say y equals x squared. Y equals x squared looks like that. And if you can draw a horizontal line anywhere on the graph and it cuts in 2 places, then no inverse. So no inverse. Function if horizontal line, I'll just use horizontal line, cuts twice. Okay. So we said, okay, this is y equals x squared, and let's look at our mapping. So if we use the point 2, y equals x squared would map, so this is f of x, and f of x in this case is equal to x squared. We square that and we get 4. Now you say, all right, well, isn't the opposite of squaring something find the square root? So wouldn't square root get us back to 2? Well, for 4, yes, it will. So 4 will get back to 2 with square root. So far, so good. However, if you find the square root of 4, you don't just get plus 2, you also get negative 2. So how do you know? If you just use square root, it's always going to give you the positive. So that's why y equals x squared does not have an inverse function for the complete domain. Now, if we decide to say, all right, let's just look for x is greater than 0, so we'll forget about that part of the graph. So we're only interested in let's do it in red here. We're only interested in that part of the graph. So we're looking at y equals x squared for x being positive. Well, that would have an inverse function because we would only get positive values of x when we do the square root of the answer. So as a general rule, though, over the whole domain, y equals x squared does not have an inverse. Okay, so let's just go through, and I like to use what's called templates when I'm doing things, just as a way to remember how to do them. So we want to find the inverse. So the first bit is to substitute. I'll just use sub y for f of x. That's my first step of my template. So instead of f of x, or over here we've got g of t, I'm just going to use y. So we've got y equals a half x plus 5. Now that was not given in the original equation, so we're not going to give our answer with y in it. We'll have to go back to this. And then the next step is to make x the subject. So it's like a formula, and we're going to have to rearrange this formula to get x by itself. Now, looking at this, we've got a plus 5. If we can isolate the half x, that will be well and truly on our way to getting x by itself. So that means we've got to take 5 from both sides, and we get y minus 5 equals a half x. And then if I just multiply both sides by 2, bear in mind I've got to multiply everything over there by 2. Why do I multiply by 2? That would get rid of the dividing by 2 here, or the half. 2 times a half is 1, so we get x equals 2, open bracket, y minus 5, or 2y minus 10. The next step is to switch x and y. So this is my template. So if I'm going to switch x and y, I get 2 outside of x minus 5 equals y. I'll just switch those two. And then my final step is to write, in this case, f to the minus 1 x instead of y. And what I'll do is I'll just bring the y over to that side and bring that over to that side, and so I get f to the minus 1 of x equals 2 outside of x minus 5. Okay, so what happens is that if I give a value of x up here, it will map it over to there. And then if I put that value in this function here, it will bring me back to the original point. So if you like, you could actually do a little check. Pick a value, say f of 4 is a half of 4, which is 2 plus 5 is equal to 7. F to the minus 1, the inverse function of 7 now, should take me back to 4. Put 7 in here, and I get 7 minus 5, which is 2. 2 times 2 is 4. So it mapped the 7 back to the 4, so it worked. And I could have used any value there, not just 4. Okay, so there's my template. I'm going to use it for these other two harder examples now. But if you can remember the red here, the template, that will allow you to do all of these. Okay, so let's just look at this one here. So we're going to substitute in for y. So y equals t over t plus 1. Now we've got to make t, in this case not x, but make t the subject. Now it's pretty tricky, this one. We've got a fraction here, so we can make y as y over 1, and we can do what's called cross multiplying, a process we've used before. And we're going to multiply the 1 times the t, and I get t. So I multiply along that arm of the cross, and then it's y outside of t plus 1. So I multiply on that arm of the cross. I can remove brackets, so that's yt plus y. And I'm trying to get t by itself, so I need to get all the t's to one side. To do that, if I take this over here, I have t minus yt is equal to y. Now I want to get the t's by themselves, and I can see now that I've got all the t's on this side and that t is a common factor of both of those two terms. So I can take it outside. 1 minus y is equal to y. And finally, I can divide both sides. To get t by itself, I've got to multiply by this bracket. And if I divide that side, I've got to divide this side. So that will allow those two to cancel out, and I get t equals y over 1 minus y. My next step is to, if I just scroll down a little tad here, next step is to switch x and y. So that's t and y. So I get y equals t over 1 minus t. And then finally, we've got g of t, so I'm going to write g to the negative 1 of t equals t over 1 minus t. Okay, so there is the inverse of this function, and you can substitute in values here for t. You'll get a new, that will map that value you gave t to a new point, and you start with that value and put it in there, and you should get back to the original one. Okay, let's use the template for our last example here. We've got h of c equals 4e to the 2c plus 3. So we'll go y equals 4e to the 2c plus 3. We want to make c the subject. When we've got the unknown as in the power, we normally take logs, and because we've got e to something, we're going to take log to base e. But we don't do that until we get rid of this 4. So we divide both sides by 4, and we get y over 4 equals, now those will cancel, and we get e to the 2c plus 3. Now when we're trying to get c by itself, we've got to get rid of the power, so we take logs of both sides, and because it's e to the power, we'll take log, natural log or log to base e of y over 4 equals, now the log of e to the power is just the power, 2c plus 3. The log of e, the natural log of e to a power is just the power, and that's why we take log to base e of both sides. Okay, we've got to get the c by itself, so we're going to get rid of the minus 3 first. So 2c equals ln of y on 4 minus 3. Take 3 from both sides, and then divide by 2. So c equals divide by 2, divide by 2. Now, instead of writing divide by 2, we can put a half out the front. ln of y on 4 minus 3. My next step is to switch the c and the y. So let's just put the c over here and that over there, and so we'll get y equals a half, open bracket, ln of c on 4, that's over 4, minus 3. And finally, we introduce the y. The y wasn't in the original question, so we can't give our answer with the y, so we write h, the minus 1 of c, is equal to a half. Just write this again, ln of c on 4 minus 3. Once again, if you put a value of c in there and calculate that, you'll get a new value, and put that new value in there for C and calculate this, you'll get back to the original point again. Okay, so the template over here in red will allow you to do all finding inverses, but just bear in mind that all functions don't have an inverse. And if you perform the horizontal line test and it cuts the graph in 2 spots, then it will not have an inverse.